In this video, my dog Jack and I are going to review the practice test for the grade 7 final exam. And in this video, as indeed in any math video, I encourage you to have a piece of paper with a pen or pencil and do these problems ahead of time. I want you to use the pause button frequently. Do these problems on your own first, and then play the video for each individual problem to see how I solve them. Okay, first, well, before I forget, excuse me, I also want to remind you that I've posted all the slides from class on Google Classroom. So as we progress in these last few days, that'll be a good resource as to what we discussed in class. Okay, the first section of the practice test, I list all the vocabulary that I think you should know really well. And I'm going to go over this briefly. I know we covered some of this in class, but let's just briefly run through these. Okay, the first one is the fact that an acute triangle is when all the angles are less than 90 degrees. So this would be an example of an acute triangle. Each of the angles are going to be acute. Next one. A right triangle has a hypotenuse. Recall, ladies and gentlemen, this is what a right triangle looks like. By definition, it has a right angle. The hypotenuse is the side of the triangle that's directly across from the right angle. The hypotenuse is a very important structure in mathematics, and you will see that in the years to come. The mnemonic that I remember is that hippopotamuses are always right. You won't see me arguing with the hippopotamus. They're always right. Right triangle, hippopotamus, hypotenuse. Next one. A constant does not change. So folks, here's an example of a constant in an algebraic expression. Notice I say expression because there is no equal sign. Expression, no equal sign. If it was an equation, there would be an equal sign. So out of these two terms, the 7 is constant. No matter what the x value is, this term will stay as 7. By definition, it is constant. Next one. Like terms are the same variable raised to the same exponent. Okay, recall that a term is separated by either a plus sign or a minus sign. So these are terms. Now, this positive sign could also be a negative sign, means that this is a term and that's a term. In this particular expression, these terms are not like terms. Why? Well, because the variable is the same, but the exponent is not. Recall the 5x has a hidden 1 right there. These exponents are not the same, therefore these are not like terms. Oh, the other thing I encourage you folks to do throughout this or any video is to take screenshots. Pause the video, take a screenshot. Okay, let's do some more. How about these terms? Folks, these are not like terms. I deliberately made the coefficient the same. I deliberately made the variable the same. But they are not like terms because the exponent is not the same. It turns out, folks, that the coefficients don't even play a role here. It's the variable and the exponent. Now, if you have like terms, you can combine them. Okay, these are like terms. The variable's the same and the exponent's the same. We can combine these and call this 5x squared. And the reason is we have 3 of something plus 2 of something, and that gives us 5 of something. And again, this something, if you're going to combine them, has to have the same variable and the same exponent. How would you handle this if you were asked to simplify this, as you will be asked later on in this practice test? Okay. First thing you do is ask yourself, are there any like terms here? Yes, there are, right here. This 2y squared and this 3y squared, they are like terms. Therefore, we can combine them and get 5y squared. I apologize. 5y squared. However, this 4x squared and this 2x, because remember that is x to the first, you cannot combine them. So if you were asked to simplify this expression, this would be as far as you could go. And that would be it. Can't get any further. Cannot simplify it. This is like having apples, 5 apples, plus 4 oranges, plus 2 chickens. You can't combine these. They're different entities, just like you cannot combine these terms. Next one. An obtuse triangle has one angle greater than 90. So this would be an obtuse triangle. This angle is greater than 90 degrees. Okay, pretty straightforward. Next. Parallel lines do not intersect. Whoops. These are parallel lines. Recall that little arrow is indicative of parallel lines. These will never intersect. That's what parallel refers to. Next. Pi is the constant used to find the area and circumference of a circle. Pi is a constant. It always equals 3.14. It has more numbers because it's an irrational number, but for our purposes in class, we're just going to use 3.14. Recall that the area of a circle is pi times the radius squared. The units are always square units when we talk about area. Remember that area has 2 A's. That reminds us that we always have square units. So, for example, we would have inches squared or feet squared. Circumference, recall, circumference, which means the distance around a circle, is just pi times the diameter. Remember, the diameter is longer than the radius. It's a longer word, and it's longer. The diameter is a line that goes through the center of a circle throughout its entire length, whereas the radius is only from the center to a point on the circle. So this is radius, and the diameter, or d, is the entire length of that line segment. Number 9, perpendicular lines form a 90-degree angle with one another. Here's perpendicular lines right there. This angle's 90, and as we'll talk about later in the video, if that's 90, then this has to be 90. They're both 90. These are perpendicular lines. That's the symbol for perpendicular lines. Next, the perimeter is found by adding all the sides of a polygon. That is true. Any polygon I give you on this quiz looks like that, If there's measurements, they could be numbers. They could be some variables plugged in here. If I asked you to provide an expression for the perimeter, remember, peri means all the way around, just like a periscope on a submarine looks around. You would add all of these lengths. So we would have 5 plus 6 plus x plus y plus 2. This, folks, would give us the perimeter. And remember, when we talk about perimeter, the units are regular. So if this was inches, whatever this came out to be would be inches regular. No squaring. You only square when you're dealing with area. Complementary angles add up to 90 degrees. Okay, you're going to see a lot of these on your final. Here are our complementary angles. Okay, this is what you're going to see on your final. You're going to see perpendicular lines as indicated by that right angle symbol, and you're going to see two angles. Complementary means that the measure of angle A plus the measure of angle B is going to equal 90 degrees. This is, in my opinion, worthy of a screenshot. Complementary. Okay, you will see that on your final. Next. Number 12, a parallelogram has two sets of opposite sides that are parallel. Okay, so here's a parallelogram. Right there. These two are parallel, and these two are parallel. Notice I made these hash marks different. Two parallel lines, or excuse me, two of these little arrows mean that this is parallel to that. The fact that this has one and this has two means these are not necessarily parallel. In fact, they're not parallel because look, they intersect. Parallelogram, two sets of parallel lines. Now, a trapezoid has one set of parallel opposite lines that are parallel. Right there. Sorry, that's not very neat. Only one set of parallel opposite sides. Look, this one is not parallel to that. So this is a trapezoid, which recall means table in Latin, and this is a parallelogram. Next one. The diameter of a circle runs all the way from one point on the circle, through the center to another point on the circle. So there it is. At the risk of being repetitive, diameter is all the way across, radius, being a shorter word, goes from the center only halfway. So if you are given the diameter, to find the radius, you take 1/2 of the value. If you're given the radius, you multiply it by 2 to get the diameter. Four x is less than 7 is an example of an inequality. I find sometimes in math it's helpful to separate things. So notice, I wrote the word inequality with a little space here and a hyphen. Look at that word. Inequality. That means not equality. It's like the word incomplete. If I were to stop this video right now, it would be an incomplete video review of this practice test, because in means not. Okay. This is an inequality. Let me show you some more inequalities. Okay. That's an inequality. I should also put an equality. That's an equality. Look, there's an equal sign. Okay, so inequality, anything but an equal sign. You could even have this. That's an inequality. Look, that's a not equal sign. Equal sign, equation, anything but not equal. Next one. Rectangles, squares, and rhombuses are all quadrilaterals. So rectangle, notice its cousin, a square, both of them have all 90-degree angles. Okay, that's where the term rectangle comes from. Again, I like to separate words sometimes. The word rect means straight, as in erect. If you're sitting erect in your chair, you are sitting up straight. The word rectitude. If someone is known for their rectitude, that means that individual is known for their uprightness, being a straight shooter, follow the law to the letter. That's what rectitude means. Okay, a square is very similar to a rectangle. However, with a square, all the sides are the same. In a rectangle, by definition, the sides are not the same. So you would have something like this, and y here, excuse me, but here all the sides are the same. Okay, let me show that a little bit more clearly. Rather than use variables, I'm going to use actual values. So a square would be something like this. All these values are the same, whereas a rectangle, you would have this. The opposite sides are the same, but the sides themselves are not all equal. Finally, a rhombus. You will see a rhombus on your test. I believe it's the last question on this practice test. A rhombus is shaped like a diamond, and all these sides are equal. That little dash means the sides are equal. Remember, the word rhombus comes from the Latin word rhombare, which means to spin. And you could see how this diamond, if you spin it, it would seemingly spin forever, like a dreidel would. Okay, here we go. That's it. Oh, these are all quadrilaterals. Quad means 4. Remember, excuse me, the 4 quadrants on the coordinate plane? These are the 4 quadrants. Quad means 4. Okay, folks, let's move on to the problems. Now, the nice thing about videos is, of course, you don't have to watch the entire video all at once. So I apologize for the length of this video, but it is what it is. Okay, here we go. Simplify. Notice, there's no equation here. Okay, if there was an equal sign and a right side of this, you might see the word solve. Simplify just means apply any algebraic manipulation and add the like terms. Okay, so let me rewrite this. And I'm going to show you how to do this. Okay. Whenever you see something in front of parentheses like this type, there is a multiplication sign there. We don't put it there, but it's implied. Okay, same thing here. Don't try to tackle this all at once. Take it step by step. First thing we do is we get our arrows popping. 1, 2. Okay, let's look at the blue arrow first. 2 times x. 2 times x. That is going to simplify to 2x. Next one, yellow arrow. 2 times negative 3. Remember in class I circled this sign as well as the number. That reminds us that we are multiplying 2 times negative 3. 2 times negative 3, 2 times negative 3 is going to give me negative 6. Okay, so now we have this entire term taken care of. All right, so let me do this. Let me make some room while we go to the other term. Okay, we're going to do the same thing. Okay. Let's shrink that. Let's get it out of the way. We're done with that. Okay, now let's focus on this guy over here. Folks, we're going to do the same thing. Here's our first arrow. Here's our second arrow, but before we do our arrow, we're going to circle this second number along with its sign. And there's your second arrow. Okay, let's do the first one. The first one is 3 times 1/3 x. Now, you see how that x is in the middle? That x belongs up top. Whenever you see that in the middle, what that really is x over 1, like this. X on top. When you align things like this, it just makes it easier as to what to do. That x goes up top. Okay, so that is our yellow arrow. Now the green arrow. It's going to be 3 times +6. Okay. What does this simplify to? Okay, the yellow arrow. You can also put a 1 over here. When you do this, when you set up fractions like this, when you put hidden ones in here, it makes everything line up. So when we multiply fractions, how do we handle that? We multiply straight across, like that. Okay. So this is going to simplify to 3 times 1, which is 3 times x, which is 3x. 1 times 3, which is 3 times 1, which is 3. Over here, 3 times +6 is +18. Okay, so this is what we have. I'm going to erase this. I'm going to move this north. I'm going to copy this plus sign right here, and I'm going to move it over here. Okay. Next move. We look for like terms, and we simplify. Okay, now look what's going on here. We have 3 times x over 3. Whenever you have something in the numerator and the denominator, and there's a multiplication sign, you are allowed to cancel these 3's. So let's do that. Boom, boom. Now what do we have? We have this become, actually I'm not going to do that. We have 2x minus 6 plus 1x plus 18. These 3's cancel out and it becomes 1. And I'm going to rewrite that as 2x minus 6 plus x plus 18. Okay. Now, folks, at this point, we look for like terms. Okay. Are there any like terms here? Remember what the definition of a like term is. Same variable, same exponent. Those are like terms. We can combine them. We have 2 of something plus 1 of something, and that's going to give us 3 of that same something. Over here, we have constants. These are like terms. You can combine positive 18 and negative 6 any day of the week, and twice on Sunday. 18 minus 6 is going to give you 12. Positive 12. Folks, here's our final answer. And there it is, choice A. Let's go to the next one. Okay, now notice the difference in this question. Here we are solving for x. Look, there's an equation. There's an equal sign. So we're going to handle this a little differently. Okay, let me rewrite it. Okay, let's analyze this a little bit. What do we see here? Well, we have an equation because there's an equal sign. We also have a left side and a right side. Let me document that. Here's the left side. Here's the right side. And we have that all-important equal sign. When you see the word solve for x, what that means is we want to get x by itself. You have to have something like this. X equals something over here. You put a circle around the side of the equation with x, and there can't be anything with it. The only thing that can be with it is this hidden positive 1. That's okay. Or if there's a 1 underneath, that's okay. You can just eliminate those with impunity. But you cannot have 3x or negative 2x or x plus 7. If you put a circle around the side of the equal sign in these 3 scenarios, you will see that x has a neighbor, or in some case neighbors plural. Not solved for x. None of these are solved for x. So our goal is to get x all by its lonesome. So let's talk about how to do that. Put the circle around it. We see neighbors. We see 2 neighbors. We see the number 2 being multiplied by x, and we see negative 6. We've got to get rid of both of them. Always go after the neighbor that's being added first or subtracted. So we're going to go after this one right there. Okay, let's talk about how to do that. Okay. How do we get rid of that neighbor, which is being subtracted from x? How do we neutralize negative 6? Well, the way you neutralize negative 6 is to add positive 6. Negative 6 plus positive 6 becomes 0. This 2x survives, but this becomes 0. It's gone. That's how you get rid of that neighbor. Now, you see that equal sign? The equal sign is the most important sign in mathematics. The fact that there's an equal sign here means these two entities on the left and right side of the equation start out equal. You've come along and you added 6 to the left side of the equation as part of your goal to get x by itself. You've got to do the same thing to the other side. Otherwise, that equal sign is no longer valid. That's why you hear the phrase, whatever you do to the left side, you have to do to the right side. That's why, because of that equal sign. Now that equal sign remains valid. We can combine these. These are like terms. So here we are. Are we done? No, because x still has a neighbor. Now, how do we get rid of a neighbor that's being multiplied by x? Notice, when we had a minus 6, we added 6. We did the opposite operation. We do the same thing with multiplication, namely, we use the opposite operation, which is division. Remember, whatever you do to one side, you have to do to the other to maintain the integrity of that equal sign. We now have the same number on the top and bottom and a multiplication sign that gives us license to cancel these 2's. And our final answer is x equals 24 over 2, which simplifies to 12. There's your answer right there. Next one. Very similar equation, therefore I'm going to do it more expeditiously. Solve. The word solve means we have to get x by itself. This is an equation. Look, there's the equal sign. How do we do it? We get x by itself. First thing we do is we add 6 to both sides. You can do it this way as well. You can use vertical orientation as well as horizontal, like we did in the last problem. This negative 6 and plus 6 adds to 0. This adds to 49. We still have a neighbor. We divide by 7, which is the opposite operation to what is being done between the neighbor and the variable. And this simplifies to x equals 7. That's a short answer. I want to take this opportunity to remind you folks that I'm going to need to collect, or actually I'd like you to submit your work on Google Classroom, and if you'd be kind enough to number what your answer is. So for this one, I would put down on your piece of paper 4, and the answer is 7. Show your work if you want to make sure you get credit. I will not take points off if there's no work shown, but if for some reason you get this answer incorrect and there's work here, I more than likely will give you partial credit, if not full credit. If you made an arithmetic error, but you did everything right, and for some reason you said 49 over 7 equals 8, I know that you meant to write 7, so I would give you full credit for that. But please number it so it'll make it easier for me to grade. I would appreciate that. Okay, number 5. Okay, a word problem. Folks, here's how you handle word problems. You take a sentence at a time, or sometimes half a sentence at a time. Okay, here we go. Jack earns 15 bonus points for every perfect score. The word "for every" means, let me write this down. The whole key to word problems, folks, is to take the words in the problem and convert it to math. Okay, so that's what I did here. This in math is the same thing as saying 15 bonus points for every one perfect score. The word "for every" is a fraction line. Okay, so that first sentence has been translated to math. Let's go to the second sentence. If he has 12 perfect scores, okay, I'm going to write that down. How many bonus points did he receive? Okay. I made this too big. Okay. Look at this math. Folks, look at the units here. Okay? Units cancel, just like numbers, just like variables. Okay, this is like having the following. If we had this, we would be able to cancel these y's because one's on the top and one's on the bottom and there's a multiplication sign. So we would be able to cancel these y's like that. Same thing up top. I'm going to put a hidden 1 here. Look at this. You have the word perfect score on the bottom and perfect score on the top. You can cancel those. The word bonus points is not canceled because it doesn't appear down below. So now what you do is you say to yourself, what is 15 times 12? The answer is 180. The word bonus point survives, has not been canceled, and that's your answer, 180 bonus points. They asked us, how many bonus points did he receive? There it is, 180 bonus points. If you use units in math, they will make your life so easy. The fact that we were able to cancel out those perfect score units helps us know that we're multiplying 15 by 12 as opposed to dividing, for example. If you were to divide by 12 perfect score, these units wouldn't work out. You wouldn't get bonus points here. So there's your answer, 180. Okay, here we go. I'm going to quit after 10 problems because otherwise the video is getting too long. It will never load up on YouTube. Okay. How many degrees is this x? Folks, this is what we call supplementary angles. Whoops. They add to 180. Okay. See this line from here to here? Here, let me draw it. Sorry. Okay, from here to here is 100 degrees. And they want to know what x is from here to here. Okay. Folks, this distance in green is 180. Okay? It's halfway around a circle. It's 180 degrees. It's just something you have to know. That is supplementary angles. Supplementary angles add to 180. And the way I remember it is, if you're eating supper, you have a plate like this. I apologize. Remember, I'm the plastic surgeon that can't draw. See that plate sitting flat? That's a supper plate. That reminds me that supplementary is 180 degrees. It sits flat. Okay. So how do we find x? How do we find x? Well, we know that x plus 100 is going to give me 180. And if that's not immediately obvious to you that x is going to be 80 degrees, and it might not be, 100 may not be such an easy number on the final. It might be something like 23.7, something like that. Solve for x. How do we do that? Well, we remember from the most recent problem, solving for x means getting it by itself. It currently has a neighbor that's being added. How do we neutralize that 100? We subtract it from this side. This becomes 0. We have to do the same thing to the other side to maintain the integrity of that equal sign. And 180 minus 100 is going to be 80. So that's your answer. I can't remember if this is a write-in or multiple choice. It's a write-in. So again, please put number 6 and 80 degrees. Let's do another one. Okay, very similar problem. Supplementary angles. Picture a supper plate right there. These angles are going to add to 180. Okay, so we're going to have x plus 42, that's one of the angles, plus 63 is going to equal 180. Okay, now there is nothing out front here to distribute, so we can remove these parentheses with impunity. Are there any like terms that we can combine? Answer yes. We can combine these. So now we have x plus 105 equals 180. Have we solved for x yet? Absolutely not. There's a neighbor. How do we get rid of that neighbor? We neutralize it by subtracting 105. We have to do the same thing to the other side to maintain the integrity of that equal sign. And our final answer is x equals 75. Next one. The complement of 62 degrees is, okay? Complementary angles add to 90. So we're going to have 62 plus x equals 90. How do we get rid of that 62? We subtract it from both sides. (90 minus 62 is 28. That's your answer. Right there. Next one. Whether you see these problems in a word problem or diagram, it's always the same. Angle 2 equals 12 degrees, and 2 and 3 are supplementary. What is the angle, measure of angle 3? Sometimes it's helpful to draw a picture. Okay. We have two angles. The first one is 12 degrees. The second one we don't know, call it x. This one is angle number 2, and this is angle number 3. Sometimes, I may have mentioned this to you, I like to use Roman numerals in this setting because this way you don't confuse any numbers that you write here with the values of the angle. So if angle 2, Roman numeral 2, is 12 and angle 3 we don't know, we know these have to combine to 180. So we know that x plus 12 equals 180. We subtract 12 from both sides, and we get x equals 168. There it is. Okay, this is interesting, and this will be the last one on this video, and then I'll move to video number 2. Angles A and B are complementary. As soon as you see that word complementary, you know you're dealing with 90 degrees. Okay, so let's write that down. 90 degrees. Okay. The measure of angle A is 3x plus 2. Okay. So we know A plus B is going to equal 90. The measure of A is 3x plus 2. So I'm going to go right from those words and put this down like this, next to that A. Okay, then I'm going to use some space. There's no reason to be crowded, folks. The measure of angle B is 2x minus 4. They still equal 90. So all I did was substitute this for A and that for B. What is the value of x? We have to solve this for x. Let's do that. Okay, let's get rid of what we don't need. Let's move this up here. Okay. Do you see a number out in front of this parentheses? Well, there's a hidden 1 there. So theoretically, we can distribute 1 times 3x, and that would give us 3x. 1 times positive 2, which would give us positive 2. But in essence, we can remove these parentheses with impunity. There's nothing out in front here of import. So here on this one, I'm not going to go through the arrow exercise. I'm just going to take what's in the parentheses and pull it down. Okay, folks, now, are there any like terms here? Do you see any variables? And if you do, is it the same exact variable? Is it the same variable with the same exponent? Remember, there's a hidden 1 here. Answer yes. This 3x can be combined with this 2x. They are like terms. They combine to 5x. Now, what about these numbers? You have a positive 2 and a negative 4. What does that combine to? Let's go to a number line to answer that question. I'm a big fan of the number line. I don't think we've had a chance to talk about it in school. Okay, there's 0. You are starting at positive 2. That's where you start. Now you're trying to combine positive 2 with negative 4. That negative sign means you go left on the number line. So let's do that. I'm going to go this way 4 units. When I do that, the first 2 units are going to get eaten up to get me back to 0, and then I'm going to go 2 more units and end up at -2. That's the way I like to add positive and negative integers. Start at +2. That minus sign tells me to go 4 in the left direction, and you end up with -2. Okay, let's clean this up a little bit. If you want to take a screenshot, that might be helpful. So we're going to have 5x minus 2 equals 90. We're going to add 2 to both sides. And we're going to end up with 5x equals 92. Now we're going to divide by 5. Get more space up here. Now we're going to divide by 5 because we do not have x by itself. X is going to equal 92 over 5. That's an acceptable answer. Perfectly acceptable. You cannot reduce this anymore because 5 is a prime number. You can't divide it. Some people might say, well, what's the decimal version of that? To get the decimal version of any fraction, you divide. So let's just go through that real quick, and that'll be the end of this video. Okay. This is the way I like to divide when I'm in this situation. I create my shoebox, and this top number topples in to the shoebox. Now, I immediately supplement that number with a decimal point, 3 zeros. I may not need them, that's okay. And then I put that decimal point right up top. Every time I do a division problem, this is how I do it. Okay, let's get rid of that arrow indicating the toppling of the numerator inside the shoebox. Now we just do what we know how to do. 5 goes into 9 once. I pause. I make sure that after I subtract, I check that this number is less than the divisor. If it's greater than the divisor, then I know this number is not big enough. I then bring down the 2. 5 goes into 42 8 times. 8 times 5 is 40. I subtract. I get 2. I check again. Is this number smaller than the divisor? It is. That means I did that correctly. I bring down this 0. 5 goes into 24 times evenly. So that's your answer in a decimal. Again, this is perfectly acceptable.